Hello, welcome to my YouTube channel. Today I'm going to explain you the strategy design pattern, maybe through a common problem. I'll not be explaining theory behind it, or I'll not refer any UML diagrams to discuss more on the strategy design pattern, but rather I would like to dig in deeper with a common problem and we'll try to find a solution using the particular pattern. So let's go to the problem. Most of you may know about text-to-speech engine. We call it as TTS engine. In computer you can see, or in your mobile phones you can see text-to-speech engines. So text-to-speech engines deals with the languages. Each text-to-speech engine may have, say, more than 100 languages. What we're going to do here, let's try to write one of the simplest entity in the text-to-speech engine called language. You know that each language may have a lot of properties like number of alphabets, maybe is it written from left to right. There are 20 more, so each language will have these kind of common properties. So certainly we can inherit Japanese language from this class or any other language. But for me, the key difference between any language is the way we pronounce it. See, for example, the way we pronounce the morning in Hindi may be a bit different because each language has their own variations in pronunciation. And if you talk about Hindi, there can be multiple variations of Hindi. Say, for example, say in TTS engine, you can see a lot of characters like Sam, Daisy, and each language will have plenty of characters, right? So British female, British male, yeah. If you start writing those classes, you'll have a class explosion, right? So class British English deriving from language may have furthermore derived classes like British English male, British English female, like that. And it's not a nice thing because you will have a lot of unwanted codes in the class and you will be ending up writing a lot of classes, and it's not that manageable. So how we can solve that problem? So I believe this pronunciation is a behavior or is a strategy we can apply. So what I'm going to do here, I'll write an interface called class pronunciation behavior or strategy. Strategy. I'm sorry. Yep. And I'll have it maybe a function call. I don't know what's the base for different pronunciation, but I'll just take it as OCL settings. So apply OCL settings. Maybe I'm completely wrong because I'm not an expert in that area. So let's write this member function as a pure virtual member function, and of course it's an interface now. Yeah. So now then let me create Indian male, yeah, public pronunciation strategy. Then I need to implement this member function. So I'll say cout Indian male pronunciation applying, something like this, right? Then I'll just try to write more, say more classes like British female, British female. So here it will be British female, right? We have two strategies for speaking in Indian male voice or British female voice, yeah. And if you want right now, I'm not going to do that, but if you want you can create multiple derived classes for each language, but it's not the scope of our discussion. So let's directly jump into the strategy pattern, or let's continue with the strategy pattern. So here, as I said, instead of a member, instead of a property, we'll create an object of pronunciation behavior here, pronunciation strategy as a in member variable here, m speaking strategy, right? Then, so for example, here language in the constructor you can pass pronunciation strategy star a strategy. Then I'll just set the speaking strategy as a strategy. The strategy, I'm sorry, I had to copy paste here. I have some problems with my editor. A strategy, blah blah blah. Cool, perfect. Now I have an API, which is the main thing, so that someone can use my language class to speak something. Yeah. Say I'll say void speak. I can pass a constant char star data, a string variable. Yeah. Here I'll say speaking data gender and character. So let's see. I'm just creating an object language Hindi equals new language. This problem. So we need to pass the pronunciation strategy. What we can do here, Indian male, right? Yeah, Indian male star Vinod equals new Indian male. So that's the strategy to pronounce. I'm just passing the Vinod object here, right? Then when we, so in fact the third party will call Hindi.speak namaste or namaste. Okay, but how are we going to set the pronunciation? So in this API, speak API, before we actually speak, we will set the strategy and apply vocal settings, something like this, and we will speak a particular language. And I'll say British female, say Daisy equals new British female. Then I'll create language star UK English, something like this, new language UK English start speak good morning. Yes, here we need to create, sorry, in the language we need to pass, it's a UK English, the pronunciation strategies, the British female here we are setting, right? Now you see, so let's return, right? Hopefully I'll compile. I haven't compiled yet. Let's see. Oh yeah. Okay, you can see here Indian male pronunciation we are applying and speaking namaste. Then we have a British female object called Daisy. We are setting it to UK language, UK English, and we have requested the Speak API to say good morning. So before good morning, it will apply the British female pronunciation. So I believe this can be one of the good practical example of strategy pattern where we have isolated the various behavior into interfaces and behavior focusing more on the composition. Uh, One of the easiest example can be, in internet everyone mentioned about animals. For example, uh, if there's a fly method and you are deriving a dog object out of it and it doesn't make sense. In those cases, strategy pattern is really good and you create those kind of behavior through interfaces. So anyway, that's all about strategy pattern. You can read much more about strategy pattern. A lot of URLs are available like source making. Thank you very much for watching.